Hey guys, my name is Sheil, also known as Artificial Coder, and today we're going to talk about how to build a spam detector hands-on. I think in this age of internet and AI, everyone is aware of what a spam detector already is, but let me explain it to you guys once again. A spam is any irrelevant, unwanted message, coming from unknown sources, and a spam detector is an automated model, kind of like an AI's, use case, which can automatically tell you whether any message is a spam or not, right? So to build a model, we need a data set. And for that, in this particular video, I'm going to use the SMS spam collection data set from Kaggle. I'm going to post the link in the description below. You can go ahead and download the data. It's super easy to download. There's a download button over here and you can straight away download it. Right, I have already done that, so I'm going to go ahead and dive straight into the Jupyter notebook. Before actually starting to code, let me first lay down the structure of how we're going to build the model. Okay, so we're going to start with loading our data set, and then we're going to clean the data because we're going to use text data and we need to do some kind of cleaning before we feed it into the model. We need to vectorize the text data, which is also again really important because you need to convert the text data into some kind of a numerical form, because that is what the model is going to use to identify some kind of patterns. And then finally, we are going to train and test. So let's first load our data set. I'm going to use pandas as PD. I think this is the most common line written by anyone who uses Python, right? I'm going to read the CSV file that I downloaded. I actually have copied the link and I'm going to just read it. Oh, Unicode error. Okay. Encoding equals to Latin. Okay, there you go. So let's see how the data looks like. Okay, so you have two columns, V1 and V2, and then there are like three blank columns which actually don't have any kind of information. So V1 is the tag that you have for the messages which are there in V2. So what we're going to do is instead of using V1 and V2, we'll use our own names. Let's say tags are df V1 and text are df V2. Okay. So now let's clean the data. So for cleaning, we are actually going to follow these steps. We'll first bring all the text to lowercase, which is really important because there are like different types of text and there are like too many variations, and we just want to make them less complex. So we'll just bring all the text to lowercase. Then we are going to remove numbers and special characters which don't hold any meaning for me in this analysis, so I just remove them. I'll remove stop words. So stop words are basically words such as is, and, the, am, was, will. So these kind of words are really important to frame a sentence, but they actually don't hold their own individual meaning. So I'm just going to remove these words because they're not going to have any impact on my analysis. And then we are going to stem all the words. So stemming is basically like, let's say, a word can be represented in different forms, such as run can be represented as running, ran, runs. So these are the different variations of the same word. So I'm just going to bring all of them together to their own, the root word. So that particular process is called stemming. So let's see how we will achieve all these things together. So for cleaning, we're going to use the NLTK library, and for stemming, we'll use the snowball stemmer. And for stop words removal, we're just going to use again from NLTK corpus. We'll import stop words. Yep. So we'll start with defining our stop words. So we'll say stop is stop words dot words, and we're going to use English Now, so let's see what it is. Stop is basically when I run stop, it'll show me like all the different types of words which are known as stop words. They don't hold any kind of meaning, but we will need them to be removed. Okay, so NLTK already has a collection of it. You can append this by adding more words that you want to remove. So let's say if I want to remove something, let's say my name, Shiv. So now it has been added. So you can actually customize it. That's basically what it means. So you can see my name over here. Yep. Now we have to define our stemmer. So we'll do stemmer equals to snowball stemmer. Again, the language is English. All right. Okay, so now let's see how a stemmer works. Stemmer.stem. Let's say if I pass running. See, perfect. So it can actually understand that running is a form of run. Let's say if I pass runs, it again becomes run because running and runs are basically two different forms of the root word run. So all right, so that makes sense. Now what we can do is let's create a function. So, and the function is going to perform all these 4 tasks that I mentioned over here in one go. So I'll just pass a list of messages, and then the output will be a list of clean messages. Okay, so let's define a function and we'll name it cleaner, because it's cleaning. And we're going to pass a set of messages. Let's define an empty list, and we are going to loop into messages. And so every individual message, let's call it MSG. So we'll say we'll first bring them to lowercase. All the words in a particular message will be first brought down to a lowercase. Then we are going to remove all the numbers and special characters. So what we're going to do is, I actually have a regular expression that can do that. So I'm just going to copy paste it. And this is basically message. So this is lowercase. This is removing numbers and special characters. Now we are going to remove the stop words. So we'll say, okay, W for W in doc, if not W in stop. Okay, so this will work because the output of this particular I also need to import another library, which is importing re, which is going to remove the numbers and use cases, and the output of this particular step will be list of words together, and that is what we're going to use to loop in and remove the stop words. Now the output of this step of removing stop words is again a list, and every word is an item of the list. So we're going to join them together and we'll add a space in between. So we're going to do this, and then we are going to clean it by stemming everything. So stemmer.stem will becomes this, and now this is the cleanest form of the message. So we are going to append the clean text list with this clean message, and coming out of the for loop, we are going to return clean text. All right, so now let's pass our text data into the cleaner. So we'll say clean text equals to cleaner text. All right, it's done. So let's see how clean our data is now. Clean text. Goes your own point, crazy available boogies, and great world, something, something. Right, and let's see what it was initially. So you can see that there were like so many variations. I'm just going to print them both together so that also we should have, let's do this, yeah. Clean text, 0. So you can see like how the difference is. So go, G became smaller, until is a stop word, so it has been removed. Crazy, the special characters, basically these period signs and these commas and all those things have been removed. And so we have basically a cleaner version of this text, right? And that is what we wanted to achieve. So this is perfect, looks really good. So basically our next step is to vectorize the data. Okay, now we have to vectorize the data. This is the most important part in any natural language processing, model building, because you have text data coming in and you now want to run some kind of a machine learning model to predict the text data into some kind of a class. But the problem is that a computer cannot understand the text data. It only understands numbers. So we have to convert text to numbers. And there are different ways to do that. In this particular video, I'm going to use something called as a count vectorizer. And if you want to learn more about it, I actually have written a blog on it on my Medium page. So you can go search for artificial coder and read my explanation on count vectorizers and TF-IDF vectorizers. These are basically two different ways by which you can convert text to numbers. So okay, so let's go ahead and see what it is and how it can be done. So I'm going to import the sklearn library, and from there we are going to pull the feature extraction and then text, and then I'm going to import count vectorizer from there. Let's define our count vectorizer. Let's call it as CV. So count vectorizer, let's say n-gram range is 0 to 2. So basically what it does is that, a count vectorizer basically counts the frequency of the words which are there in a sentence, or in our case, a message. So, a count vectorizer, basically, if we give an n-gram range of 0 to 2, it's basically going to count the frequency of individual words and also the combination of words. Basically, if you combine two words, it becomes a phrase, right? So that's what it's going to do, and that is really helpful because sometimes words individually have some other meaning, but together, like when you form a phrase, it becomes some completely different thing. So sometimes it's really good to use n-grams. So because our data is different, we have to do the encoding. If you remember, I did that while reading the CSV file. And maximum features is going to be 20,000. So you will see this a lot, right? Whenever you're going to define a count vectorizer, a lot of people will use maximum features as 20,000 because, as a thumb rule, a normal human being uses 20,000 words. It has 20,000 words in his vocabulary. So that's what we generally assume, that whatever message comes in is written by some kind of a person. So that person will have 20,000 different words in his vocabulary. So that is what the maximum range of words that we are going to focus on in this particular analysis. So now we are going to fit it and transform our clean text. So basically what we're doing is we are passing the text data, and the output of this particular step is basically a set of numbers, which is the frequency of every word in that particular text. And I'll show you how it runs. So these are a few things that you need to do. Get feature names. Let's call DTM equals to, I'll show you what it means. We're converting it over to an array, and the columns are basically the feature names of features. Okay, so instead of, let's say, throwing in the clean text that we have, let's throw some random text. Hello world, how are you doing? And if we run this, so the output, basically the DTM is going to be basically this. So you can see this are you doing, these are the different combination of words which are there in this particular sentence, and then what it is doing is it is counting their frequency. So if I say you, so you'll see that you has become 2 now because the frequency of you is twice now. That's great, right? And then there are 8 spaces in between. So 1, 2, 3, 4, 5, 6, 7. I don't know why 8 is here. Okay, and we need to remove it. So this is the column that comes in and I don't need it. Yep, now it's removed. So now this is perfect. So this is what we're going to do to our so now, this is what we're going to do to our list of data that we have already, clean data, and then we're going to pass a clean text, and this is it. Oh, yep. So this is the numerical representation of the data that we already have. And you can see the dimensions. It has almost 20,000 columns, which is perfect because that we had already mentioned while actually defining a vectorizer. So let's now use this to train a model. So before training, actually we have to divide our data set into training and testing. So for that, from scikit-learn model selection, let me first import train test split. And now we're going to split our data into the X train, X test, Y train, and Y test, and we are going to use string test split on DTM, and the tags are tags, if you remember we used it initially. So these are the tags of all the messages, and we'll say the test size. So basically defining how the split will be 10%. So we're going to use 90% data to train a model on and 10% to test it. And because it is randomly doing it, let's say we'll use a random state of 40. Okay, so the train and test split has been done. Now we have to choose the model, the classifier, because we have 2 different classes, which is spam and not spam, basically. So we are going to use a classification model. In my case, let's use random forest. Random forest classifier. Let's say print running model. Let's define our random forest classifier as random forest classifier. We'll have 200 iterations and jobs, basically using all the processors, and bootstrap equals to true. Now let's fit it to our our training data. And let's use this training to predict our test data. And let's then print out the accuracy, which is basically the score of prediction and Y test. And jobs. Okay, running the model. So I think it's going to take some time. So I'm going to go straight ahead when the output is shown. Okay, so the model got trained, but there was some error because somehow it's not calculating the accuracy, because I'll have to use some kind of other scorer. So all right, so the model got trained, but there was some error because of this particular code. Somehow it's not able to calculate the score. So I'll just rerun it again, and this time, instead of using this, we'll use scikit-learn's metric calculator, which is scikit-learn.metrics, and we're going to import accuracy score, and then we're going to print accuracy score prediction, comma, y test. Let's wait. All right, so we have our accuracy is like 97%, which is really good. But I also have another set of codes which will calculate the precision, recall, and F1 score. So let's try that as well. Yeah, perfect. So you can see that the precision is almost 1 in both the different classes. Recall, again, close to 1. These are really good numbers. So I think this particular model really performs really good. So basically, yeah, this is how you build a spam detector. So thank you guys. Thank you for watching this video. If you like the video, if you learned something new, please give me a thumbs up, comment your feedback, subscribe, also share this video with your friends. And until next video, peace out. Thank you.